What makes lightning a huge static electricity spark? Imagine a giant spark jumping from the sky to the earth, lighting up the night with a flash. That's what lightning is, a massive static electricity spark on a scale you can't even imagine. But how does it get so powerful? Well, it all starts high up in thunderstorm clouds. These clouds are full of tiny ice crystals and water droplets that are constantly bumping into each other because of strong winds. When they collide, they generate static electricity, just like rubbing a balloon on your hair. The lighter ice crystals tend to move upward, while the heavier water droplets sink down, causing a charge separation inside the cloud. This means positive charges gather at the top of the cloud, and negative charges gather at the bottom. The ground below the storm also starts to become positively charged in response to the negative charges overhead. As this charge separation grows, the electric field between the cloud and the ground becomes super intense. Normally, air acts like an insulator, stopping electrical flow. But when the voltage difference becomes too high, the air's insulating ability breaks down. This is called electrical breakdown, and it turns the air into a conductor. Once this happens, a stepped leader, which is a zigzagging path of electrons, begins to move downward from the cloud at speeds up to 60 miles per second. At the same time, a positive streamer rises from the ground. When these two paths meet, they create a complete electrical circuit. This connection allows a huge flow of electrons, sometimes as many as 1 billion trillion electrons, to rush along the path in less than a millisecond. The voltage involved can reach between 10 million and over 100 million volts. This enormous flow heats the air to around 50,000 degrees Fahrenheit, which makes the air glow white-hot and creates the bright flash we see. The rapid heating causes the air to expand quickly, producing the shockwave we hear as thunder. That's why lightning appears before thunder, since light travels faster than sound. The main difference between the static shock you get from touching a doorknob and lightning is the amount of energy involved. Both are caused by charge separation and sudden discharge, but lightning involves billions of times more energy. It's a spectacular display of physics in action, showing how the same basic principles of electricity operate on a colossal scale in nature.